Okay, so 8.3 is a lot like 8.2, at least the first part is, okay? Remember 8.2 was about exponential functions. So now we're going to talk about logarithmic functions or logarithms. And the cool thing about exponentials and logarithms is they're inverses of each other. And the inverses mean that they invert their x and y values. So their properties are just inverted. So anything that has to do with the x now has to do with the y. And anything that has to do with a y on an exponential now has to do with the x. So just like we talked about last time, this is kind of new. This is going to be new for us. If we remember exponentials were y equals b, I'm going to make a good b to the x. Okay, logarithms are y equals log base b of x. And I'm going to actually write it a little bit differently later on in the lesson, so it makes a little bit more sense for you. But remember, log is just a function, okay? There's a log button on your calculator. You can't use it all the time, but you'll learn more about log. So don't get caught up on the fact that you don't know what a log is, okay? First thing that you need to look at, if we look at this, if we remember from last one, the domain for an exponential function was negative infinity to infinity, and the range was 0 to infinity. So those have flip-flopped. So if you look at this graph, it's a little bit different, or like the exact opposite of the graph from 8.2. Okay, and these points are the exact opposite as the ones from 8.2. So when we plug in 1 over b, we get -1. When we plug 1 in, we get 0. And when we plug in b, we get 1. Okay, nothing really crazy new there. Okay, here is some interesting points are points that you need to be aware of, okay? It says 2 of the most widely used logarithms are the common log, which has a base of 10, and that's written as this, log base 10 of x or log of x. This is the button that's on your calculator. Okay, you can only use that button when it's base 10. Okay, and then the other one is the natural log, which is a base e, and e is a number that's like it's like pi. Okay, it's 2.7, I think it's 1818, not exactly sure off the top of my head, but 2.7 something, and that is written as log base e, or the ln of x. This is also on your calculator. Okay, they're the most commonly used ones. Okay, so some of you are like, great, Miss Bustle, what's a log? So this is how you're going to remember it, and you can just accept it. It's kind of crazy. This is how I teach all my kids. You need to remember that logs are bay, and I know bay is a little bit outdated, but just hang in there with me, okay? Logs transform into exponentials using bay. So log of your base answer equals your exponent, okay, transforms into the b is the base, e is your exponent, and a is your answer. So when it's in log form, it needs to spell bay. And b stands for base, a stands for answer, and e stands for exponent. So for example, on all of these, we're going to rewrite them in exponential form. If it's exponential form, that means that there's no log. Okay, so if it is a log, then it spells bay. So we have the b, the a, and the e. So if I'm changing forms, that would be b, or 4, to your exponent is 3, and a is your answer. 4 cubed equals 64, which is true. Okay, the next one, b, number b. Logs are bay. B, A, E. Base, answer, exponent. So this is in exponential form. 5 to the exponent of -2 equals 1 over 25, which is a true statement. Okay. Next problem is C. So this is base, answer, exponent, because logs are bay. So I'd write 65 to the exponent of 0 equals 1, and that's true. Okay, and then I always put this one on here just because I think it helps people understand that it really doesn't matter what the numbers are. Okay, this triangle is the base, smiley face is the answer, and star is the exponent. So this would mean triangle to the star equals smiley face. That's how we transform them from exponential form to logarithmic form. Okay, so the next examples would say, rewrite each of the following in logarithmic form. So meaning that this needs a log. So they don't spell bay. We need it to spell bay. Okay, so if that's the case, then we're going to label these exactly. I'm going to zoom in. Exactly what they are. 3 is a base, 4 is an exponent, and 81 is the answer. So if I'm writing it in log form, I would say log base b, or 3, because that's my b, of 81, that's a, equals my exponent 4. Now it spells bay. So the answer is log base 3 of 81 equals 4. That's how we transform from exponential form to logarithmic form. Okay. Next one. Same thing. This 10 is the base. -2 is the exponent. And 1 over 100 is the answer. So I would say log base b of 10. Okay, log base b, which is 10, of the answer of 1 over 100 equals -2. You can write it like that. The better way to write it, because it's log base 10, we would just say log of 1 over 100, because that is the common log that has base 10, so they don't write it. You can write it either way. This one's technically better than the other one, but they mean the same thing, so we don't need to get really picky about that. Okay. The next one, C, says it has no log in it, so I need to put a log in it. So 6 is a base, 1 is my exponent, 6 is my answer. So log base 6 of 6 equals 1. Base, answer, exponent. Logs are bay. Okay, and then the last one we have, okay, we go through base, exponent, answer, log base m of g equals k. There's my base, answer, exponent. Okay. Couple things that are kind of cool. These are just basic properties, and you don't really need to memorize these because you can kind of figure them out from the previous things that we've learned. So it says use the properties of logs to evaluate the expression. My thing is this: if it ever tells you to evaluate something, that means it wants you to solve. But on these problems, we don't have an equal sign. So what I do specifically, what Miss Bustle does, is instead of memorizing all of these specific rules, I'm going to set it equal to something, let's say K, because I like that letter. And then I'm going to solve for K. I'm going to figure out what that number is. So the way I solve is I'm going to change forms. Whatever form it starts in, I'm going to change it the other way. So this is in log. So this is log base 10 of 10 to the -4. And I know it's base 10 because nothing's there, and that's the common log. Okay, equals K. So I'm going to change forms. I'm going to go base, answer, exponent, would tell me that I'd have 10 to the K equals 10 to the -4. Here's my base, here's my exponent, here's the answer that I had. Okay, so if that's the case, this goes back to our 8.1 assignment where I know that K equals -4. Okay, I'm going to do most of these, so it's going to get a little bit more clear as we go. Okay, next one. I'm solving. I need it to equal something, so I'm going to set it equal to F. Sure, you can set it equal to whatever you want. Okay, I'm changing forms to solve. This is not in log form. This is exponential because we have something to some power. And I know it says ln, which is the natural log, but that's in the exponent. So if that's the case, then this is a base, this is an exponent, and that's my answer. So if I rewrite this in log form, I would have log base e of f equals ln of 6. And you're like, those do not match, Miss Bustle. Except for they do, because the log base e is the ln. So you have the ln of f equals the ln of 6. So from that, we know that f equals 6. Okay, let's see. I'm gonna skip C and D, okay, but I'm gonna do E and F. And we're gonna do, it's the same thing. Okay, I'm gonna set it equal to something. Equal to, try to avoid letters that look like numbers so you don't get confused. So I'm gonna do, looks like M. Okay, and so this is in log form, so it spells bay, logs are bay, B-A-E. So I go 2 to the m power equals 32. And you're like, what the heck? Well, this is exactly 8.1. This is where we need to make the bases the same. So I get 2 to the m equals, and I know 32 is 2 to the 5th power. So if that's the case, I know m equals 5. So log base 2 of 32 equals the number 5. Okay? Last one in this section. Same idea. It's a log, so we're going to set it equal to some letter. I'm going to set it equal to a p. This is my base, answer, exponent. So I get 4 to the p equals 1 over 64. And just like 8.1 assignment, I need to make the bases the same. I can't ever go bigger, so I'm going to have to go smaller. So I'm going to try and make it so it says 4 to something equals 4 to something else. First thing I'm going to do is I'm going to write this as 64 to the negative 1 power, because I'm going to flip it because I don't like fractions. Okay, and then I need to figure out what 64 is with a base 4. So this side's going to stay the same, but 64 to the 3rd power, so 4 to the 3rd to negative 1. So 4 to the 3rd is 64 to the negative 1, so I get 4 to the p equals 4 to the negative 3, so I get p equals negative 3. Okay, there's that section. Solve the following. Same thing. This is just having you solve for x, so it's literally the exact same thing. Whenever you solve logs or exponentials, you are going to change forms. Okay, if you start in log, go to exponential. If you start in exponential, go to log. Okay, so first example is this one. It's in log form. Logs are bay, B-A-E. So I'm going to change forms. 2 to the x equals 8. Base, exponent, answer. Okay, so now I'm going to try it just like 8.1. I'm going to try and get them so their bases are the same. So I get 2 to the x equals 2 cubed, x equals 3. Done. Okay, bases are the same, so exponents have to be the same. Okay, problem B. I know this video is long, guys. This is kind of a longer lesson. Just embrace it. It's really not that bad. Just keep practicing. You got this. Okay, B. These are all in log form, so logs are base. 7's my base. X is my answer. 2 is my exponent, so I get 7 squared equals x. Well, 7 squared is 49, so x equals 49. Okay. This one, logs are base. Base is x. Answer is 125, and exponent is 3. I get x cubed equals 125. You're like, how do I solve that? Well, we're going to undo this exponent, so I'm going to take the cube root of both sides, and I get x equals, you can do this in your calculator, you know 5 times 5 is 25, times 5 is 125, so I get x equals 5. Okay, and then the last one, we did it. I need to change colors because I'm getting bored of that. Okay, everyone's going to panic and be like, what in the heck? This is crazy and long and scary. It's not. It's the same thing. Okay? So log form. This is a base. This whole thing is your answer, and 2 is your exponent. So I'm going to change forms. I get 4 squared equals 3x minus 2. 4 squared is 16, so I get 16 equals 3x minus 2. I'm going to add 2. I get 18 equals 3x. Divide by 3, and I get x equals 6. Okay? Nothing crazy, you guys, I promise. The more you do, the more work you show, the more you trust in the fact that logs are base answer exponent, and that transforms into exponential, b to the e equals a. You got this, okay? You can do this. Hang in there. I know this is rough. If you're really struggling, set up a Google Meet with me and let me answer your questions, okay? Good luck this week.